Good morning, children. Today we will start the last chapter of our chemistry, that is structure of the atoms. In the previous chapter, we had studied about atoms and molecules. We had studied that matter, it is made up of atoms. Now, the existence of different kinds of matters is due to the different atoms constituting them. For this, we had studied law of constant proportion and law of your conservation of mass. So, these things we had studied, but looking at the wide variety of matter which is present in the world, there was a doubt really whether this atom is really indivisible. Atom is indivisible. This was proposed by Dalton in his theory that atom is indivisible, but there was a doubt on this. So by experimentation and all, the scientists tried to find out actually what is it, whether it is divisible or indivisible. So first indication that atoms are not divisible comes from the study of static electricity. Now what is this? This relates to your experiment which we used to do when we all were kids. What we used to do? We used to take a scale or a comb and we used to rub it on the hair. Then we used to bring it to the bits of paper, and when we bring it to the bits of paper got attracted to that scale. See here the activity 4.1. Comb dry hair. Does the comb then attract small pieces of paper? Yes, you saw that. You did it practically, that the comb attracted the pieces of paper. Now, this clue gave that yes, atom is not actually indivisible. Atom is divisible. An atom consists of charged particles. So, children, what are these charged particles which is present in the atom? You in general know that. Atoms, they consist of electrons, protons and neutrons. I told you in the previous chapter while teaching that chapter. So you know this, but this was actually here that it was discovered by J.J. Thomson. Electrons was discovered by J.J. Thomson. What are electrons? Electrons are charged particles. They are negatively charged particles. They have negative sign. They are negatively charged particles. Okay, and they do not have any mass. That their mass is negligible. E. Goldstein, he identified protons. And these protons are positively charged particles. That is, they have plus sign. So, protons are positively charged particles. Electrons are negatively charged particles. Electrons, their mass is negligible, whereas the mass of this proton is approximately 2000 times of the electrons. Means electron has mass, proper mass. Proton, electron mass is negligible. Proton has mass, and mass of proton is 2000 times as that of the electron. Mass of proton is 2000 times as that of electron. So whenever we think of mass, we will think of our protons, not of electrons. Okay. Then comes your structure of atom. Now they got an idea at that time that atom consists of electrons and protons. So when electrons and protons are present in atom, how this structure of atom would be, where these protons are present, where these electrons are present, they used to think of that, and thinking this, they thought of making the structure of atom. J.J. Thomson, he was the first person who gave this structure of atom. He first proposed model of atom. So you can see here Thomson's model of atom. What he said, what he gave in his model of atom, he said that this model of atom is similar to Christmas pudding. Or he also told that it's just like watermelon. You can think of watermelon, you just cut watermelon from half. What happens? You can see whole red portion over the top surface, and in this red portion there you can see small black seeds inside it, somewhere here and there. Okay, so this whole red portion was what? Positive charge or positive sphere. This whole red portion was your positive sphere. That is, if this whole top surface is your atom, then the red portion is the protons, and those black seeds, they are electrons. We can relate this to Christmas pudding. How we can relate? The edible part, the whole edible part is your protons or positive sphere, and the nuts which are here and there, 1-2 pieces, that are your electrons. So this is Thomson model of atom. You can see the structure diagram here. Now he proposed, you can see what he proposed. An atom consists of positively charged sphere and electrons are embedded in it. Second, the negative and the positive charges are equal in magnitude. So the atom as a whole is electrically neutral. This point was very important. So I have explained you about this Thomson's model. It means what? What actually this is? Now atom, what it contains? Electrons. It also contains protons. Now in an atom, number of electrons is always equal to number of protons. What I said? Number of electrons is always equal to number of protons. Means negative charge and positive charge both are equal. So both are equal, they get cancelled, and hence an atom is electrically stable. Otherwise atom wouldn't be stable. We can see atom is stable and there is existence of matter. If atom was not electrically stable, then or neutral, then there wouldn't be existence of your matter. So it is due to this point, it is due to this reason that the magnitude of positive and negative charges are equal. Number of protons is equal to number of electrons. So atom is electrically neutral as a whole. Then after that comes Rutherford model of atom. Now Thomson, he explained the atoms are electrically neutral. This was there, but his structure of atom was not accepted. Why it was not accepted completely by all the scientists? Because he couldn't explain many of the further observations and conclusions by many of the experiments performed. Like Rutherford, he performed an experiment in which this model of atom couldn't explain or reason out why such observations came. So that is not in your syllabus, so we are not going to take that in detail. You just read it and go through. Now the actual thing is, but this is important, Rutherford's model is important because he was the one which he concluded that Thomson's model is not the one, the actual structure of atom. He, from his experiment, gave conclusions that the present structure of atom slightly different to that, but it's almost similar. What was this? You can just see the present structure of atom. This is the one. What is that? In center what is present? Nucleus is present. In center of atom, nucleus is present, and then round the nucleus you can see there are shells. These shells are also called as orbits. Here you can see 4 shells are there. K shell, L shells, M, K, L, M, N. First, second, third and fourth shell. So these shells are also called as orbits. What Rutherford told, that protons are present in the nucleus. Protons are present where? In the nucleus of the atom. And whole mass of the atom is also present in the nucleus. Protons are present in the nucleus and whole mass of the atom is present in the nucleus. Now where is the position of electrons? So electrons are present in the orbits. Electrons are present in these orbits. K, L, M, N orbit, you can see here this orbit or this shell, the electrons are present. And electrons are revolving around this nucleus. He told that. Okay, so this is your actual structure of atom. But there was something which Niels Bohr, he explained that these electrons are present in special or discrete orbits only, and these electrons are not present everywhere in all the orbits. They are present in particular orbits and where they do not radiate energy. So this was the actual structure. That is, here the nucleus is there in the center, and in the nucleus what is present? Protons is present, and the whole atomic mass of the atom is present in the nucleus, and electrons are present in the shells or the orbits which are outside around the nucleus. Okay, then after that in 1932, J. Chadwick, he discovered third subatomic particle, that is neutron. He discovered neutron, and this neutron is neutral. It does not have any charge. It does not have any charge. So actually what atoms contain? Atom contains electrons, protons and neutrons. Atom contains electrons, protons and neutrons. Electrons, they are negatively charged particle. Protons, they are positively charged particle. Neutrons, they are neutral particles. Okay. Electrons, their mass is negligible, and protons, they have mass. See, you know atomic number, I have told you in the previous chapter also while teaching. What is atomic number? Atomic number is the number of protons present in an atom. Atomic number is number of protons present in an atom is the atomic number. So what is atomic mass number? Atomic mass number is given by the sum of the number of protons and the number of neutrons. Now where these neutrons are present? These neutrons are also present in nucleus. So in the nucleus what actually is present? Protons and neutrons, because atomic mass is given from the is present in the nucleus. So when mass is present in the nucleus means protons is present and neutrons is present. Both protons and neutrons are present in nucleus and electrons are present in the shell. Okay, so this is about. You can see here I have shown you the diagram or the structure of your atom. Nucleus, K, L, M and shell. K shell is your first, L shell is your second shell, M shell is your third and N is your fourth shell. Now, how many electrons can be present in which shell? If there are 10 electrons, we can put it directly in N shell? No, you cannot put it in N shell. You cannot put it directly anywhere as you wish. You will have to, I told you, these electrons are present in discrete orbits, in particular orbits only. So, what happens? First, they will go in first shell. Whatever the electrons, first they will go in first shell. And the maximum capacity of the first shell is 2 electrons. Maximum capacity of first shell, that is K shell, is 2 electrons. How you will get that? The maximum number of electrons present in the shell is given by the formula 2n square, where n indicates your the number of shell, which number of shell it is. So for K shell, here I have calculated 2 into 1 square, that is 2 electrons. For L shell, it is 2 into 2 square, that is 2 into 4, that is 8 electrons. So M, it is 18 electrons. Fourth shell, it is 32 electrons. So this is the maximum capacity or maximum number of electrons which can be present in each of these shells. And always in the first shell, 2 electrons will go. So when I am talking about 10 electrons, first shell, 2 electrons will go. After that, how many electrons are left? 8 electrons are left. Now those 8 electrons will go in the second shell, that is L shell. Okay, so you can see here there is something which is very important in this. You can see here 2 electrons in first, second shell 8, third 18 and fourth 32. But there is something which is called as octet structure. Now what is this octet structure? I have told you atoms, they react. Okay, atoms of various elements, they react to form different compounds and different substances. Now why do they react? What is the reason of reacting? So the reaction, they react to attain stability. They react to attain stability. When can they attain stability? When they will have octet structure. Now what is this octet structure? Octet structure means what? 8 electrons should be present in the outermost shell. Outermost shell is your valence shell. Outermost shell is also called as valence shell. So always to attain octet structure, that is making in outermost shell 8 electrons, this is why this octet structure has to be attained. And to attain this octet structure, because without that they are not stable, they are not completely stable, or they are reactive. If there is 8 electrons, like you see your inert gases, you can see in inert gases, in helium it is 2, so it is inert, it is not reactive, because the first shell capacity is full. Okay, Then comes your neon, 10, 2, 8. So second shell capacity is full. First shell capacity is full. Second shell capacity is also full, 8 electrons. So it is also not reactive. Hence it is inert gas. So this octet structure is very important, and when they attain this octet structure, they attain stability. So to attain this octet structure, they react, or to attain stability, they react. Now how this happens, we will see that. Let us see with an example of sodium atom. Sodium atom, atomic number is 12. Okay. Now atomic number is 12. I told atomic number is equal to number of protons, that is equal to number of electrons. I told positive charge and negative charge, both are equal in magnitude. So both are equal. Protons how many? 12 protons. Now electrons how many? 12 electrons. Now there is another term which is called as electronic configuration. Now what is electronic configuration? Electronic configuration, I have written here the definition in this page. You can see, you can note it down, even in textbook it is there. Electronic configuration is what? It is the distribution of electrons. How many electrons are present? 12 electrons are present. So how these electrons are distributed in the shells of sodium atom? That is electronic configuration of sodium. So what is electronic configuration? Electronic configuration is the distribution of electrons in various shell of the atom. Okay, this is electronic configuration. Now valence electron also. What is valence electron? Number of electrons present in the outermost shell is called valence electrons. What is valence electron? Number of electrons present in the outermost shell is called valence electron. And what is valency? Combining capacity of an atom of an element is called its valency. Valency, again I repeat, combining capacity of an atom of an element is called valency. These three are something very important. You need to relate all this. All three are related to each other. So all the points which I have written here are the key points which you need to remember, so that you can easily find out the valency if you know the atomic number. If you know the atomic number of any element, you can find out the valency very easily. Though I have told you that page to learn the whole table from 1 to 20 elements, to learn it, their atomic number, atomic mass number, their valency, all things I told to learn. But still we can find out the valency if we know the atomic number. How we can do that? You can see here how the electrons are, where and how much electrons are, how they are distributed. Let us see that. So electronic configuration, you can see in this nucleus what is present, protons are present and neutrons are present. So leave that. Electrons we will see. Electrons in first shell, 2 electrons. Yes. Then in second shell, how many are left now? Now 9 electrons are left, because 12 are there. So now 9 electrons are left. So in second, how many will go? 8 will go. Second shell capacity is 8. So 8, 1, 2, 3, 4, 5, 6, 7, 8 electrons you can see. Then how many are left? 1 electron is left. Now this 1 electron will be going in the third shell. Third shell will consist of 1 electron. Now there is no more electrons. So your last shell will contain, or valence shell, it will contain 1 electron. So what is valence electron in this sodium? 1. Because in the outermost shell, how many electrons are present? 1 electron. This is for sodium only. In this way you can find for all the elements. More we will study in detail, I will again tell you, but still you just get through this. Then electronic configuration is 2, 8, 1. 2 because in first shell 2 electrons, then second shell 8 electrons, so 8, and third shell 1 electron, so 1. So 2, 8, 1 is the electronic configuration. Valence electron is 1. Valency is 1. Valency is 1. Why this valency is 1? You need to understand it. Now, to attain octet structure for sodium, how many electrons are needed? Like now here in the last shell 1 electron is present. It needs how many electrons to complete its 8 octet structure? It needs 7 electron. So taking 7 electron is easier, or giving out 1 electron is easier? Naturally, taking 7 electrons means no one is ready, no one will give this sodium 7 electrons. It is very easy for sodium to give out this 1 electron. So it is due to energy considerations. very less energy will be required in giving out this electron. Actually, no energy will be required, but taking 7 electrons will require lot of energy. So, due to this energy considerations, taking 7 electrons is difficult for sodium, and giving out 1 is easier. Hence, the valency of sodium is 1, because it gives out 1 electron, and then it will consist only of 2 shells, that is octet structure is completed. Hence, the valency of sodium is 1. So, this is your sodium, how the electrons are present, how the electrons are distributed, and the structure of sodium atom. This I have drawn here, the structure of sodium atom, and I have also explained about all these basic points. You can see in your textbook the schematic atomic structure of first 18 elements. I have told you to learn the names of all the elements, first 1 to 20. So, you need to draw this structure for 1 to 20 elements also. You need to understand this structure also. See, hydrogen, helium, only 1 shell. Then lithium, beryllium, boron, all these 2 shells. Lithium, it is 3. So, 2, 1. 2, 2. Then boron, 5 electrons. So, 2 in first shell and 3 in second shell. So, this way it increases. Okay. So, this you will have to just study it out. This is how you are going to practice it, and more about this we will be doing in